Interesting question we have. It says for a point P in the plane, let D1 and D2 be distances of point P from these lines. Okay, so one thing is quite obvious that they are talking in XY plane because everything looks like in X and Y only. So let's have them. So can you draw the first line? X minus Y is equal to 0. Yeah, it's kind of Y is equal to X, isn't it? Slope is 1 passing through origin. This is your first line. X minus Y is 0. Can you also draw your second line? Yes, the slope is negative 1. Okay, so let's draw it here. Passing through origin. This is your second line. That is X plus Y is equal to 0. Now they are looking for a point P. Let's say my point P is somewhere here. And what are they saying is D1 and D2, the distances. Okay, the distance from the first line, they are calling it D1. And the distance from the second line, they are calling that distance to be D2. Okay, what next? The area of the region R consisting of all points P lying in the first quadrant of the plane satisfying this condition. Now, did you understand that? They're just saying that all the points P, they are looking for regions where such points P lie. So, P is a variable point, it's not just one point. Okay, it's a variable point which can lie anywhere here. Okay, I want to find out area of that region which satisfies this condition. Got it? Okay, so what do we do? Just assume one arbitrary coordinate. You can also assume xy. Let me assume alpha beta just to distinguish it. Okay, this point is this. Now this condition has to be satisfied. So can you give me what is d1p? So this is the distance formula right here. Let's apply that here. Okay, d1p. Okay, using that formula, distance of this point from this line. Instead of x, I'm going to write alpha. Instead of y, I'm going to write a beta. There is no c. And a and b are 1 and minus 1 respectively. So 1 square plus 1 square modulus. Okay, that's my d1p. Now, can you also write your d2p? Yeah, distance of this point from this line. Okay, this is the line. So again, you're just going to replace x and y with alpha and beta. Again, no c here. Under root 1 square plus 1 square. And what do you want it? You want it to lie between 2 and 4. Okay, you have to simplify this. Okay, let's do the simplification. Okay, below this is also root 2 and this is also root 2. I can multiply by a root 2 throughout. So I'm getting alpha minus beta modulus plus alpha plus beta modulus lies between 4 root. Now what's our problem? Removing the modulus sign, right? That's our thing. Okay, if I can remove modulus, I'm able to solve that. Okay, now what do we know about alpha and beta? Then say that it is in the first quadrant, right? So my alpha is positive and so is beta. Okay, what happens if I know both are positive? The second modulus I can remove, right? Because if alpha and beta both are positive, then alpha plus beta is always positive. I can remove that modulus. But what about the first one? This one I have to assume, right? I have to assume like if alpha is greater than beta, okay, then you can remove the modulus. Okay, let's assume that. Okay, if it is so, then I can remove that modulus and just write alpha minus beta because it is positive. Okay, and then you getting this. Okay, now let's concentrate on this. Okay, what does this condition means? Alpha is greater than beta. That means you are saying your x is greater than y, right? Or y is lesser than x. So what is the region when y is less than x? This side of the region, right? This is y is less than x, right? This line is dividing, the red line is dividing into two regions. The above one is y greater than x and the below one is y is less than x. Okay, so now we are concentrating, when I said this, then we are concentrating on the lower region. Okay, okay, now let's solve it. See, beta beta gets cancelled. 2 alpha I'm getting here, I can divide by a 2. So I get this. Okay, alpha should lie between 2 and root 2. Now, what do I know now? So let's say this is root 2. Okay, so alpha is root 2 here and alpha is, let's say, 2 root 2 here. Okay, so the region we got is, do you see that? The region we got is this region. Okay, whose area probably we should be looking for, this region. Okay, now, what do we do? Similar thing, right? I could have also assumed that if alpha is lesser than beta, right? In that case, what will happen? Okay, instead of alpha minus beta, I will be getting beta minus alpha, correct? And alpha plus beta is still the same. Okay, lying between 2 root 2 and 4 root 2. Yes. Here also alpha alpha now is going to get cancelled. I'm getting 2 beta. Yes. Then I will divide by a 2, all of it. Okay, so I'm getting 2 root 2. So when you assume that alpha is lesser than beta, that means you are saying that your x is lesser than y or y is greater than x. Okay, in that case, you are concentrating on this above region of that line. Okay, and when you said that your beta should lie, that means your y should lie between root 2 and 2 root 2. Okay, so here, okay, this is root 2 and this point is, let's say, 2 root 2. Okay, so what area are we looking for now? This area, right? This area, this whole area. Okay, now combinedly, okay, the red area and the blue area, how much is that? Your wish, right? However you want to figure out, you can figure out. Okay, but what I will do is, I will see, this is the bigger square. Okay, and this is a smaller square. Okay, I will just take out from a bigger square the smaller square. The bigger square has side length 2 root 2. Okay, so 2 root 2 whole square minus this square is root 2. Okay, so root 2 square, that's it. So this is 8 minus 2 and that is 6. So we got that area to be 6, which satisfies this condition. Yeah. Interesting one, right? Okay, see you with another one.